Good morning, everyone. I have to apologize a little bit because I don't have a lot of voice, and I guess speaking 40 minutes will be the last thing I'll do today, so I hope you appreciate the presentation. A few words about me. I'm a researcher in Rome at La Sapienza, and since a few years I've been doing research on machine learning and more recently on deep learning. And I've seen deep learning go from something relatively small, so a niche thing in the research community, and then it's swallowed entire research fields. At the university now, everyone is talking about it. Then in the last 2 years, I've seen it go as a big thing for everyone. So now all developers are interested, all companies, all big companies, startups, people that develop by home, webmasters, mobile applications. Everyone seems to want to do deep learning just because it's a cool thing. And I travel quite a lot, and I've seen a lot of presentations on deep learning given by a huge amount of people, and they basically all start in the same way. So I've seen, for example, this graph like 100 times already. And how many of you have already seen these sort of things in other presentations? Well, people use this sort of thing to say, okay, we have machine learning, and machine learning is cool, but at some point the performance of machine learning, whatever that means, plateaus with the amount of data. So we are not able to use appropriately all our data. But now we have deep learning, and deep learning looks kind of magic because you just throw more data on top of the program and the accuracy will improve and improve and improve. It doesn't matter how much, what performance you want to reach. You can just throw more data on top of that and it will go up and so on. And the media, of course, have not helped because they're doing a lot of journalists are doing a lot of pieces on deep learning, and they have this sort of titles. So, for example, everybody is saying about the superhuman accuracy that deep learning is getting everywhere. So, in image recognition and speech recognition, a lot of other things. And of course, deep learning is beating us at everything. Like in this case, it was Go, and after DeepMind won the game of Go, everybody seems like it was a huge thing, and artificial intelligence was very close. And of course, there's a lot of money on deep learning. You can just make a startup, make it a little bit bigger, and sell it for a huge amount of money, so hundreds of millions, billions of dollars. And of course, again, artificial intelligence is coming. If you read journals, it looks like only a couple of weeks are left. Then we will have super intelligence, Terminator, whatever. I think that the thing that shocked me the most was that I started to see memes on deep learning, which meant that, you know, it went viral. Every developer wanted to use that. I saw this on Facebook, actually, which was kind of shocking. I mean, why would you talk about research on Facebook? I don't know that. A lot of memes, actually. You see them a lot. Okay, it's probably more about the people I know than about Facebook in general, but this is pretty accurate. So everyone thinks he's the head of Facebook, head of research at Facebook, but then again, he's just downloading a library and using it. That's more or less the deep learning experience that most people have. And one of my passions is literature, and there is this very nice quote by Agatha Christie. It says that, okay, humans can make mistakes, but they're nothing compared to the mistakes that a computer can make, because a computer is blind. It doesn't reason, actually. It doesn't think. So if you do a stupid program, it will do some very big mistakes. And there's another quote by a researcher, in this case, an ex-Amazon researcher. He wrote a book. Everybody bought this book. And he says, okay, we're worrying about artificial intelligence. We're worrying that smart machines will take over the world. But the truth is, stupid machines have already taken over the world. And stupid machines like these machine learning techniques, stupid because you just develop them and you put them in the world and you think there's some sort of intelligence, but they make mistakes. And a lot of people are affected because of this. So whenever I do a talk about deep learning, what I want to stress, and that's basically the only thing I would really like to stress today, is that deep learning is not different from any other machine learning techniques. At the very heart, it's just a tool that we can use to get data. We have data, we put data on top of deep learning, and it can find some regularities on this data. And this regularity is according to some objective that we specify. So for example, this could be accuracy or cross entropy or some other performance metric, and that's the only thing it does. It doesn't reason, it doesn't think, it's not intelligent. I have these two corollaries, and the first one means that a deep learning program will always be as intelligent, and a machine learning program in general, as the data it gets. So you have stupid data, you have wrong data, we will see you have racist data, you have racist programs, you have stupid programs. And it's only as smart as the objective it optimizes. So the truth is that in many companies like insurance and banks and tribunals, accuracy is not the only thing. So it doesn't really matter only about the accuracy. There are many, many other things that matter in the real world, and they matter in an economic sense, in a juridic sense, and so on. Which means that if you just blindly follow these advertisements, you take deep learning, you apply it in your programs, in your life, like you are a blind horse, then you will get into a lot of trouble because of this. And now I will show you some examples also with some code. And real problems, so social problems, economic problems, a lot of people today are already affected because of this, and I will show you some examples. So let me start with the things I think it's the most pervasive and the most interesting, it's discrimination. So some of you may work on natural language processing, and today deep learning has become a huge thing in natural language processing. For example, we do machine translation using deep learning, keyword extraction, sentiment analysis, all these things. And all these things started in 2012, basically, when some people of Google developed the first so-called word embedding technique. It's not really deep learning, but it has become a core component of deep learning. I don't want to get too technical in this talk, but the main idea is simple to get. So when you do natural language processing, you have words, and words are symbols, and symbols are very difficult to process with a computer, and particularly with a deep network, with a neural network, with a machine learning program, because it doesn't reason in terms of symbols. It reasons in terms of numbers, real numbers, so 3.25, square root of 4. So a word embedding is just a tool, a neural network that Google developed to transform symbols into words. Okay? So you have a camera, for example, it gets maps into a set of numbers, and the computer can reason about this number. And I have a small demo with some code. These tools were very, very good. So a lot of people started to use them. And in fact, you can use them very easily in your code. Here, for example, I will download this method that I talked before. Again, not really deep learning, but there are also techniques like this using deep networks. You can download it. And for example, in Python, you can download this library. It's called GenSim, and you already have this tool at your disposal. So you can do machine learning on words, on sentences, on tweets. What do they do? Okay, here I'm just limiting myself to a few words because my computer is not really powerful here. But you see, you take, for example, a word like man, you give it to the model, and you get a bunch of numbers. And these numbers are a representation, a machine understandable representation of this word. Now, why people were so obsessed about word embeddings is that you can do things like this one. You can do algebra on the numbers. For example, you can take the numbers for Rome minus, this is the mathematical minus, so you're subtracting numbers. You can do minus Italy plus France, and you get Paris. So it's sort of like, it looks like these numbers, they have some semantic meaning. They understanding what the words mean. In this case, you take the capital city of Italy, you subtract Italy, you add France, and you get the capital of France. So this was really amazing at the time, which meant that everyone started to use them, and they become an essential tool. But then, some years later, after a while, some researchers said, okay, but these numbers, these models are trained on data. So let's look at the data. How was this data? And for example, they found things like this one. So if you do the same thing, so if, for example, you take doctor minus father plus mother, you get some highly discriminative things, like nurse in this case. So if a father is more likely to be a doctor, for this model, a mother is more likely to be a nurse. And they found a lot of this discriminative behavior in the tool. And the problem was that a lot of them, for example, this is a gender axis, and they found that for this model, a man was more likely to be an architect, a hero, a legend, and a woman was more likely to be a librarian, a stylist, a dancer. So this is something that if you say these sort of things, you won't get a job, you will get into all sorts of trouble. And what's strange about this is that hundreds of papers, hundreds of applications, these sort of things are everywhere, okay? They're in your cell phone, they're in the web apps. A lot of things were published and done before it was even noticed, even discussed. So this is a paper from 2016 with a very nice title. So man is to a computer programmer as woman is to a homemaker. Why? Because people were only looking at accuracy, and if you only look at accuracy, these sort of correlations will actually increase your accuracy, okay? But the truth is, in the real life, these are very important things that they are starting to discuss. For example, a couple of people from Microsoft published this article in Nature, and they call this a blind spot, okay, in artificial intelligence research. A blind spot because people develop this model in the lab and they only care about accuracy. But the truth is these models are deployed in the real world, and in the real world you need to care about a lot of things. You need to care about society. And in society, for example, racism is not a good thing. Your algorithm are not allowed to be racist, are not allowed to be discriminative, because think about that. This sort of algorithm are also used, for example, where you look for a job, which means that if you're a woman, if you look to a job, you will get more advertisements for stylists and dancers, and a man will get more advertisements for engineering. So they're reinforcing biases that we already have, and it's not a good thing. You say, okay, but who cares? Well, a lot of people care. For example, some years ago, before deep learning, Nikon went into a lot of trouble because the algorithm was racist. He didn't recognize Asian people. He thought they were blinking. He wouldn't allow you to make a photo of an Asian woman. So a lot of bad publicity, a lot of money spent to curtail these sort of things. But actually, okay, a nice paper talking about this, the rise of the racist robots. It's not an economic problem, it's a social problem, because people last year found that these racist algorithms were used in the US tribunals. So they were used for helping judges decide if a person was likely to commit again a crime or not. And for example, white people, low risk, black people, high risk. Even if these black people has only some juvenile misdemeanor, so it's not really a big criminal, while this white man has an armed robbery, okay? And they were using this, and judges were using these tools to decide that this woman should stay in prison and this man should go out of prison. And this was a big scandal for the entire US system, actually. And it's not just US, it's not just tribunals, because, for example, Google is talking and Facebook are talking a lot about a thing called fairness, because if you're a bank and if you are an insurance, for example, you do this model and you only care about accuracy, but do you really need to you only care about accuracy? The answer is not, because in practice, when you decide, for example, if you want to give a loan to a people, you need to be careful that your methods of doing that are not discriminative. Okay, in this case it was an abstract thing with orange and blue bows. But for example, you don't want to give more loans to white people and less loan to black people, because if people find out that race is a problem for you, again, you will get into a huge amount of trouble, where we're talking about people that can sue you, you're getting to the media and so on. And what Google is emphasizing a lot, for example, is that this is only a problem in the mindset of the researcher, because, for example, enforcing fairness is actually pretty easy. But you need to know that this is your objective. So if you are an insurance company, you need to understand and you need to design the system in a way that this is your objective, not accuracy, not what you find in the general tutorials about deep learning. And if you don't do that, the algorithm won't do it for yourself, you get in troubles. Okay, but this is something, you know, very easy to understand, very simple to explain. Now I will show you something a little bit easy to understand, which is also a big problem. And the problem is that in the real world, actually, you do your model in the lab and it works and you get a good accuracy. So you show this accuracy to everyone, to your managers, to your friends, whatever. You write it in your journals. But in the real world, people are not nice. You know, people try to break your things. People try to exploit your things. So some people started to ask themselves, okay, but can we break neural networks? Can we take advantage of neural networks? And surprisingly, the answer was yes, it's very easy actually. So again, another, I'm sorry, but I had to change laptop at the last moment, so this demo is not live, but you can see the results anyway. So again, in this case, we're talking, it all started with image. So image classification was the first big thing that neural networks did. And everybody started to get interested because of this, okay? So they were getting superhuman accuracy in recognizing any kind of object. So hundreds of thousands of types of objects inside images. And the source code, the neural networks, were released in open source, so you can download them. You probably have them in all your phones. You have them on Facebook. You have them in cameras. You have them everywhere. And it's as simple as this. So you just load the model here. See? One line of code. Then you take a photo, and since we're talking about internet, you know, it's a cat. And you can just ask the neural network here to predict what things are in this image. It's 2 lines of code. And for example, it would tell you that, okay, it's a cat, not just a cat, but the species of the cat. Okay, it's very precise. It works incredibly. So it looks like it's even more intelligent than us. It can recognize them faster and better. And I didn't know the species, okay? So I could just say that this was a kitty. But again, okay, can we attack this system? Can we exploit it? And you can download again another library from the internet. There are a lot of them. For example, this one has a nice name. It's called Fullbox, right? What it does, it creates another image, okay? And this image looks more or less the same to us. So it's a cat, for example, in this case, but with a different color, right? But everybody would recognize this as a cat, right? So a neural network is more intelligent than us, shouldn't have any problem. Turn out that if you give it this image to the neural network, it will tell you that it links very dangerous animals. So run, path, or a fox, or even something stranger. So these are called adversarial attacks. And the funny thing is that you can do this every time, for every model. You can always design images or sounds or whatever the neural network is that can fool the neural network. It can make the neural network think that it's seeing a different thing. Well, this seems to you like a very stupid image. You would never get fooled about that. And this was, maybe some of you have heard about that because this researcher wrote about this influential piece in his blog, Andrew Karpathy. So it says, okay, we can break image classifiers, okay? So all of these are recognized as ostriches, which of course they're not. And you see here the difference between this one and this one's just a few pixels. You will never see this. You don't see any difference. Even if I have a very high resolution monitor, you would see no difference. So how do they do that? Seems easy because basically they have access to the model. So they know the model, they know the parameters, they know everything about that. So they can design some optimization process to create this sort of noise. But then people said, okay, it's not a very big problem because in reality you don't have access to these models. So these models are proprietary, they're on the other side of the cloud, you don't know them. Not true. Because, for example, people found out that you can design universal adversarial attacks. So, for example, you can design this sort of noise, simple noise. You can add this noise to any image, and almost every time any model will be wrong. Okay? This will be recognized as a Labrador. This will be recognized as a Labrador, a Chihuahua. Okay, every time, every model, doesn't matter. Your model, the model of Google, the model of Amazon. And it's not just for images, for words. So this is a question answering system that is used actually. And they found out that this year actually, you can just add a few random words here, design in a certain way, and it will get the wrong answer every time, all the time. And you can do this in reality. You can do physical objects that fool, for example, cameras in driverless cars. You can do this in 3D. Okay, you can get an object that is recognized as a cat from every orientation. So now you ask, can you protect against this? We don't know. So researchers are doing a few things. You can make a system more robust if you know about them, but almost no one knows about this. But then the attackers get smarter. Right now there is a sort of arm race, and we don't know actually how big of a problem this is. But if you're doing a system and if you're putting it into a real world, there are a lot of situations where you need to be careful because people can attack the system. Okay, and maybe this is a camera that recognizes a security threat and it will see a cat. And you're armed with an AK-47, okay? You're going around and nobody will see you. And also, now I'm going a little bit faster because still have 20 minutes, I guess. But there are a lot of situations like this, okay, where you think that the system is magic, and you don't understand that in the real world, a lot of people actually are smarter than you, can find ways to break these systems, because they're nothing more than a bunch of parameters that were optimized to do a certain kind of thing. For example, a lot of people think that data, deep learning is about data, and data gets exchanged. So you can download data, you can get data from a provider, you can move data inside a company. And people think that making data anonymous is very simple. You remove the names. Data is anonymous, it doesn't have any names. It's not true. And this is known from a lot of time. So this is 2015. You can identify data by cross-referencing with other databases, for example. In this case, they showed that they could track people inside a supermarket, even if they had no access to the names. So they had almost 100% accuracy in this case. A similar thing happened to Netflix. Everybody of you now know Netflix. A few years ago, he made a big challenge. He gave some data to people, and there were no names on the data. And after that, sometimes researchers found out that you could identify all the people just by going on EMDB, so another website. You could cross-reference that, and the data was not anonymous anymore. And Netflix had to remove the data. It's not legal to download it anymore. And you say, okay, but this is a problem of data in general. Yes and no, because, sorry, let me... Because deep learning has bigger and other privacy concerns. A deep learning system is just a big neural network, okay? It has a lot of parameters. And it's also capable of memorizing things. So a lot of your data set will get memorized somewhere inside this big neural network. And so people started to ask, okay, but can this information leak from the system? Can you get back the information about the data set? Again, the answer was yes. So for example, you can do membership attacks. You can understand if a person was used as an example for training a neural network. And you can do all sorts of things. And you see, you can have very good accuracy in identifying people inside data sets. And again, if privacy is a big concern of yourself, you need to defend against this attack. This defense must be done by you. They're not intelligent. But even worse, now Google is interested a lot for distributed environments, so it wants your data to train its models. So maybe you don't know, it calls that federated learning. So a lot of data gets sent from mobiles to the Google servers to train models better. And researcher again found that you can actually intercept this data, even if it's anonymous. They put a lot of privacy tools on top of that. It's anonymous. You can reconstruct data from your cell phone. So maybe you can reconstruct private photos that were in your cell phone, even if the photo itself was not exchanged as it is on the web. Okay, even also on the security threats, this is my favorite example. Maybe you heard about that. It's called a dolphin attack. Let me play the video. How many of you have heard about this sort of thing? Now we'll show you one guy here. So this is incredible. So a few researchers have found that you can, so speech recognition in Siri, for example, is done using a deep neural network. And they found that you can activate all these systems, Siri, Echo, Nest, whatever, using ultrasonic sounds that you don't hear. So you don't hear anything, and your systems get activated. And what's so cool about this attack is that, you know, it exploits a mixture of things. So it exploits the hardware, because microphones shouldn't receive ultrasounds, but in practice they do. So they exploited this thing, and they exploited some problems from the deep neural networks. So in this case, you had a deep neural networks that was put inside an hardware, and the researchers were able to devise a very sophisticated attack that exploits all of this. Now this is being repeated. We're trying to understand these sort of things. But the thing was that it works everywhere. It worked for Siri, it worked for any sort of speech recognizing systems. And it was very, very dangerous, because it means that I can activate all your houses, everything in your house, maybe your cars. These systems are getting this everywhere. And you don't understand this by just looking at accuracy, because accuracy is computed on your data. Your data is only by people. You will never see these sort of things. This needs bigger testing, a larger testing. This needs units inside companies that are dedicated only to this, okay? And the last thing I wanted to talk is related to this. So even if people are not trying to attack you, so even if you don't have any enemies in the real world, deep learning is just a very, very small part of an industry. So if you go inside a company and they have data scientists, they have people that collect data, they have managers monitoring things, serving infrastructure, deep learning and machine learning are a very, very small component, okay? And again, this is something that is getting a lot of attention in the research community, but not many people know about these sort of things. This is called technical debt. It means that if you use these sort of things inside your systems, it looks like they're magic, but in practice they are accumulating some problems that will show everywhere else. So you might start to have problems here, 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 everywhere. So you have a quote here. So they say it's dangerous to think that deep learning is so powerful and all this power comes for free, because in practice you can have entanglements, feedback loops, consumers that use your data that are not declared and will change the data, and data dependencies, configuration issues, whatever. I mean, in practice, inside an enterprise, you have huge problems that depends on the fact that these systems communicate between them and they're interdependent one on the other. And this machine learning system will introduce some problems that are specific to them because of data, because of how they are trained, because of the fact that the data can change and the system doesn't adapt. And you need to put in place ways and protocols to control all of this. They show some, if you read this paper, I encourage you to do this, because they show you some examples where inside Google, and inside Facebook, and inside Microsoft, they didn't take into consideration these things, and they get into a huge amount of problems because they didn't know where the problem was coming from. Maybe they used this system, and 3 years later, a huge problem presented itself, and they didn't know about that. So I reserve 10 minutes for if you have any question on this topic. But if you're interested, just a little bit of advertisement. We opened a meetup in Rome last year, and we're getting quite a nice feedback from the audience. So if you ever come in Rome, please come visit us. And we also opened an association to promote a little bit this awareness also on these sort of things and on machine learning and deep learning in general. You're all very welcome to join us in our next events. Thank you very much.